Okay, so today is also direct and inverse variation, but it's word problems. So before we get started, let's remind ourselves, what is the formula for direct variation? All right, write that down, please. Direct variation, y equals kx. And for inverse, the formula is y equals k over x. Okay? All right, so you just need to remember whether we have x or y or not. When you have direct, you're multiplying by k. And when you have inverse, k is being divided. Okay? All right, so let's start with number one. A spring extends or compresses in direct proportion to the mass being supported. If spring A extends 3 centimeters when supporting 100 grams, how far will it extend when supporting 20 grams? So let's start with the first sentence. A spring extends or compresses in direct proportion to the mass being supported. Okay, so a spring extends, so let me use the letter E, or you could have used C for compresses. So a spring extends in direct proportion. So when I see those words, direct proportion, I'm going to go ahead and put the K right there, and then I need to multiply it by the other variable. It's in direct proportion to the what? To the mass. So I'm going to use an M for mass. Okay. If spring A extends 3 centimeters, so let's go ahead and plug that in. What does 3 centimeters get plugged in for?
That's 13.
Sorry. All right, 13 has been a whole bunch. Okay, so 13 goes in for E because that's how far it was extended. Do I know K? Let's put a K. Do I know the mass? What is it? 100 grams. Okay, so plug in your numbers, 13 and 100, and then you have to figure out what K is. So what do you do to both sides? Divide by 100. What do you get for K? Okay, so you could leave it a fraction. What is it as a decimal? Okay, you can use either one because that is a rational number, so 0.13 is a nice decimal, okay? All right, now we need to answer the question, how far will it extend when supporting 20 grams? So let's go back to the original formula. How far will it extend when supporting 20 grams? Do I know how far it's being extended? Do I have a number to plug in for E? No. So I'm going to put E equals. Do I know what K is? Yes. K is 13 over 100, or you can use the decimal. And do I have a mass? And it is 20. Okay. So 13 over 100 times 20. All right, 2.6 is fine. 2.6 what? Centimeters. So that's how far it's being extended. Okay. Any questions? Number 2, the change in Fahrenheit temperature varies directly as the change in Celsius temperature. If a temperature difference of 5 degrees Celsius produces a temperature difference of 9 degrees Fahrenheit, what change in Fahrenheit will be produced by a change of 35 degrees Celsius? So again, I'm going to go back to the sentence. That's important. The change in Fahrenheit temperature varies directly for the change in Celsius. So start with the very first thing. What's the first thing they're telling you about? Fahrenheit. So I'm going to use a F equals varies directly. That means I put a K and then I'm multiplying by the next variable, the change in Celsius, so I should use a C. Okay, so that's how you're setting it up. F equals KC. If a temperature difference of 5 degrees Celsius, so what does 5 get plugged in for? C, Celsius, produces a temperature difference of 9 degrees Fahrenheit. So 9 gets plugged in for F. Okay. So just like yesterday, you need to find what K is.
Would C be negative 5 won't be
No, that's a good question. For our purposes, no. If you made them both negative, you end up getting the same answer. So it's okay to do that. Just be consistent. All right. So divide both sides by 5. So K is 9 over 5. And now we need to answer their question. What change in Fahrenheit would be produced by a change of 35 degrees Celsius? All right, so let's go back to our original formula. Do I have a Fahrenheit temperature to plug in? No. Do I know what K is?
Yes.
What is it?
9/5.
9/5. Do I have a Celsius temperature to plug in?
Yes.
35. And that one's ready to just put in your calculator. 9/5 times 35. 63? 63 what? Degrees Fahrenheit. Okay. Questions? All right, number 3. At a constant temperature, the pressure of an ideal gas varies inversely as its volume. If the gas occupies 6 cubic inches at a pressure of 20 pounds per square inch, what is the pressure if the volume is decreased by 2 cubic inches? The temperature remains constant. All right. At a constant temperature, the pressure of an ideal gas varies inversely as its volume. All right, so the pressure of an ideal gas varies inversely as its volume. Okay, so here's what we need to start with. All right, so what are they talking about? What's our first quantity? It is pressure. So let's use the letter P equals. Varies inversely. What do I need to do for that? K divided by something. Okay? And what are you dividing it by? Volume. So put a V. Okay? All right, you got to be careful here. If a gas occupies 6 cubic inches, is 6 cubic inches a pressure or a volume? Volume. It's volume. And so here's a couple clues on this one. So they're telling you here it has a pressure of 20. So 6 cubic inches can't be pressure because they've told you here pressure is 20. So that's one clue. Another thing is cubic inches are always volume because here's where that comes from. If you have a cube, how do you find the volume of it? You multiply length times width times height. So how many things are you multiplying? 3, and so it ends up being cubic. Okay, you're multiplying it 3 times. All right, so 6 cubic inches is a volume. And what goes in for pressure? 20. So the pressure is 20. Okay. All right, how do I get K by itself on this one? Multiply by 6. So K equals 120. All right, and we need to answer their question. What is the pressure if the volume is decreased by 2 cubic inches? So is the volume 2? No. What is the volume? 4. So it was 6, and it's been decreased by 2. So 6 decreased by 2 becomes 4. So we'll go back to our original formula. So I don't know the pressure. I'm trying to figure that out. What do I know K is? And what's my new volume? 4. So 120 divided by 4 is 30. 30 what? It's a pressure. Good. Pounds per square inch is technically how that would be written. You won't lose any points on your quiz for that, but it is good to talk about. Number 4, the rate of travel over a fixed distance varies inversely as the time. If a runner covers the distance at a rate of 1 mile per hour in 5 minutes, how fast is she running? If she takes 4 minutes to cover, should say the same distance. All right, so again, you've got to go back and set up your formula. The rate of travel over a fixed distance varies inversely as the time. All right, so I've got 2 things right here. I have the rate of travel and distance. Which one am I going to choose for my formula? The rate. The distance is fixed, so it's not going to affect anything. All right, the distance is fixed, so that's not going to affect anything. So the rate varies inversely, so K divided by what? Time. Okay, varies inversely as the time. All right, if a runner covers the distance at a rate of 1 mile per hour, what's 1 mile per hour going for? Rate. And 5 minutes goes in for time. So multiply both sides by 5, so K is? Okay. All right, so go back to your original formula. It says, how fast is she running if she takes 4 minutes to cover the distance? So do I know the rate? No, I don't have anything to plug in for rate. Do I know K?
Yes.
What is it?
5.
5. And do I have a time? 4. Okay. So 5 over 4, that doesn't reduce. You could make it a decimal. What would it be as a decimal?
1.255.
All right, and what is that? Miles per hour, good. Okay. All right, heart rates and lifespans of most mammals are inversely related. A cat lives for about 15.2 years on average and its heart rate of 126 beats per minute. If a hamster has a heart rate of 634 beats per minute, how long will the hamster live? All right, I got to go back to the beginning. All right, I got to go back to the beginning. Heart rates and lifespans are inversely related. Okay, so what variable did they give me first? Heart rate. What do I have to do for inversely related?
You have to divide.
K divided by something. What's the other thing we're talking about here? Lifespan. So I'll use an L. Okay. All right, am I going to plug in 634 first?
No.
No. Is there another number that goes with 634?
Yes, per minute.
Well, is there another number? What?
126.
No, what does 126 go with? 15.2. So you have to be careful. You've got to plug in 126 and 15.2 first because those are the two numbers that go together. Okay? Those are the two that go together. So what am I plugging in 15.2 in for? Lifespan. And what's the heart rate that goes with that number? 126. Okay. All right, so multiply both sides by 15.2. What do you get for K?
1,115.
Okay, so that's K. So you always have to find K before you can answer the question. So now, if a hamster has a heart rate of 634, how long will the hamster live? So we'll go back to this formula. Do we have a heart rate? Yes. What's the heart rate? 634. Do we have a K? Yes, 1915.2. All right, what do you have to do on this one to solve it?
Divide by, multiply by L.
Multiply by L. That's what you're technically supposed to do first. So that gives you 634L equals 1915.2. Because those would cancel. And then what would you do last?
Divide by 634.
Divide both sides by 634. And L equals... Okay. What would that be? 3.02 years. Okay. All right, if an elephant lives for about 70 years, how many times per minute does the elephant's heart beat? Okay, so we're still using the same formula on this one. If you notice, this is just part B of the same question. So you have the same setup, have the same formula. Do I have a heart rate? No. Do I know what K is? Yes, I already found K. What was K? Okay. And then do I have a lifespan?
Yes.
70. Okay. All right, what are you getting for that one?
27.2. Oh, for that.
Yeah, 27.36. What would that be? Beats per minute. Okay. All right, Number 6, the number of possible string sections to be cut from a 4-inch piece of string varies inversely with the length of each of these string sections. Which equation models this relationship? What's important? Varies inversely. Very good. Varies inversely. So for that one, it needs to be k divided by something. Does anybody know what k is on this one? 4. So let's read this again. The number of possible string sections, so that's S, to be cut from a 4-inch piece of string varies inversely with the length. So they're already telling you that k is 4, and then it has to be divided by what letter? L. What answer choice is that? B. Okay. What was the other possibility? A. Okay. All right. Number 7, last one. Suppose the price of pizza varies directly with the square of its diameter. At Jack's Pizza Parlor, a 16-inch pizza cost $14.50. How much less would a 14-inch pizza cost? Make sure to round your constant of variation to the nearest hundredth. All right, so let's go back up to the first sentence and set it up. The price of a pizza varies directly with the square of its diameter. All right, so what's my first variable? P for price of the pizza. Varies directly is going to be k times something. What am I timesing it by? Let's set it up first. Square of its diameter. How do you write that? How do you write square of its diameter? D squared. Good, Tim. Square of its diameter means d squared. Okay? All right, now let's plug in our numbers. A 16-inch pizza goes in for what? What's 16 inches going to be? Diameter. Cost how much? $14.50. So that goes in for price. Okay. You can do this all in one step. Just make sure you're dividing by 16 squared. Just make sure you're dividing by 16 squared. And what do you get for K? Good. What did it say to round it to? So how many decimal places is that? 2. Okay, so that's what we did. How much less would a 14-inch pizza cost? So let's go back up to the original equation. Do I know the price? Do I know K? 0.06. And then I have to put 14 what? Squared. I have to put 14 squared. All right, so what do you get for the price?
11.76.
Y'all agree with that? 76? Okay. Is that the answer? What did the question ask? How much less would this pizza cost? So how much was the original pizza? $14.50 minus the new pizza. Is that right or not?